We're going to be reacting to insane illusions. Are you ready?
I guess.
Let's do it. I got a special one for you.
This is the first part of a 3-part illusion. What do you see? Well, there's a window and it's turning.
I see a rectangular
it
shape.
Stops
Looks like
and
a window.
reverses direction.
It's going back and forth.
So the window is oscillating back and forth.
Yeah.
That's what most people see when
Well,
they
you can
look
see
at
the
this
light.
illusion, except that's not what the window's actually doing. It's on this turntable,
Yeah,
and it
I
is
see more of a piece.
rotating continuously. This is known as the Ames Window illusion.
I'm confused.
And I saw it on an old Australian TV program called The Curiosity Show.
Oh, it looks
And
like it's going.
I was curious. So in this video,
It looks
I'm
like
gonna
it's
dig
swaying back and
deeper
forth,
into
but it's
this
just going in a
illusion than
circle.
anyone has before. You know, the window itself is not a rectangle, but a trapezoid.
See?
You can see this
Oh.
side here is much shorter than this side over here. And that is essential to the illusion.
So when it spins.
Also essential, it is shaded to make it look 3D, but it's actually just a 2-dimensional card with the same image on both sides.
Oh, so it looks like it's
now
just
that you know
going
exactly
to a
what
certain
this
point
object
and
looks
flipping
like
back
and what
around.
it's doing,
But it's actually going all the way
perceive
around
the
360.
I just
rotation
said
rather
that.
than the oscillation.
Don't act like you know this
I still-
illusion.
It still looks to my brain like this window is going back
That's crazy.
and forth.
Except you can see the lighting on it. It kind of
Okay,
just.
here's an idea. I'm going to attach this Rubik's Cube to the short side of the trapezoid.
How does a
so we
Rubik's
can
Cube
keep
fit on
track of
there?
it
Piece of paper.
as it goes around.
I don't know. I think it's like
You
cardboard.
ready?
Oh.
Okay.
So watch the
Oh.
Rubik's
Rubik's
Cube.
Cube
Is what I'm
is
saying.
going
The
around.
Rubik's Cube will go in front of
Everything
it.
seems normal.
It looks like it is, but it's not.
Oh, yeah.
but
So
it is.
it's in front now.
What? is
Oh,
that?
I see.
It
That's
looks like
crazy.
The Rubik's Cube is continuing to go around, but the window is oscillating back and forth.
I'm trying to picture it
There
still.
goes the Rubik's
hard.
Cube around the back. I don't even know what's happening.
How do people sit around and think about this?
I don't know.
Whoa. Look at that. It looks like the Rubik's Cube is out drifting by itself out in front of the whole illusion.
What
What
the
is
heck?
happening?
It's like perfectly shaded.
Okay,
I
new
know.
plan. I'm going to take off the Rubik's Cube and I'm going to put a ruler right through the middle of the window. And so we can't possibly
he
be
balance
fooled
that
by the
ruler?
illusion.
I don't know
right?
because I thought that was like a piece
Okay,
of
here we go.
cardboard.
But now it looks like the ruler is
Okay, the ruler is
going to come through the
rotating
window.
Around.
It looks like it's going to go
Wait,
through it.
now the
Well, it
window
was
is going
gonna-
backwards.
See,
Whoa.
look.
Whoa.
That's crazy,
The
dude.
ruler is going
My
through
eyes.
the window. It is doing things which I know are physically impossible, but that is how my brain is seeing it.
I don't
Look,
see
here
it.
we go again. The ruler is
What do you
turning
mean?
around with the window.
Look, it looks like the ruler is
Right
spinning
about
and going
here,
through the window. Right there.
starts
See?
going backwards, but the ruler keeps coming. What is even?
It literally looks
how
like
is
the
this
ruler
possible?
is going through the
This
window.
doesn't make any sense.
I don't see it going
But
through the
that
window.
is the way my brain interprets this. It
It
clearly
looks like the
prefers
ruler is spinning and
illusion
cutting,
I
over
understand,
cutting
seeing
through.
what's
I
really
don't see it
happening,
like
the
that.
continuous rotation.
How do you see
Maybe
it?
because I already I
So
know it's
why
just going
is
like
this?
I
How
see it
does
like
the
that.
illusion work? Well, it
Like
was
I don't see it
created
as the
by Albert
illusion.
Ames
Maybe it's because I
back in
already know.
1947.
Like I already know
And
what.
before
do you know what
becoming
I
a
mean?
researcher, he
Don't
wanted
act
to
like
be
you're
a
an
visual
illusion
artist.
master.
You know
So
how
he was
sometimes you
fascinated
see
by
something
how people
before though,
perceive shapes and shading.
before you look
And
at it.
according to him,
Yeah.
Like, because
the
he told
key to
me,
this illusion is that we're
like I
all
wish
used
he
to living
waited
in
and didn't tell me first and
rectangular
then
boxes,
showed me.
essentially.
Wait, let's see
You
that.
know, houses and rooms where virtually all of the corners we see are 90-degree angles. Doors, windows, tables, and chairs are full of 90-degree angles.
Oh, because we're so
This
used to
is called
seeing.
the carpentered environment.
We're so
But
used to
unless
seeing
we're
90
looking
degree
straight
angles.
on at something, the angles we actually see are not 90 degrees. I mean, the images that form on our retinas are typically trapezoids of different shapes and sizes.
Oh,
Oh.
that makes sense.
Now, from extensive experience, our brains know they really should be rectangles and right angles. So our brains use these strange shapes to infer depth information, which in our rectilinear world is almost always correct.
This guy's
But
smart.
not in the case of a trapezoidal window that our brains assume to be rectangular, hence the illusion. Now, if this carpentered world hypothesis is correct, well then you'd expect people with less experience of rectangles in their environments to be less susceptible to the illusion. And to test exactly this, in 1957, Harvard psychologists tried the
Oh, that
Ames
one
window
looks weird.
illusion in South Africa with 80 children aged 10 to 14. 40 of them were living in the city of Durban, full of rectangular
Rectangles.
buildings, doors, and windows. The other 40 were from nearby rural communities where they lived in round huts with few prominent 90-degree angles. When subjects were seated 10 feet away from the rotating Ames window with both eyes open, 60% of the urban group reported seeing the window.
This is what Harvard does with their money.
But in the rural group, only 17.5%
Test oscillating triangle. I'm
saw
just
the
kidding. It's a
same
cool thing.
thing.
I guess.
So the results were consistent
I
with
see.
the carpentered world hypothesis. The kids with less experience of rectangles were less likely to fall for the illusion. But that's not the whole story. When seated 20 feet away and with one eye closed, the illusion was much more convincing. Now, 90% of all participants saw the window oscillating, and there was no significant difference between urban and rural groups.
I'm
That
too
means
dumb for this.
Something else must be
Just
going
kidding.
on over and above our experience with rectangles. In fact, you can get a similar illusion without any straight lines at all. This is the De Heer circle. When
De Heer
rotating
circle.
continuously, it
Pretty
also
fancy.
appears
The
to
shadow
oscillate back
goes
and
away.
forth. So what's going on?
Oh, it's because the
Well,
shading.
both of these illusions make use
looks
of a technique
thick.
called anamorphosis, which has been used by
I think it's
artists
2 pieces
for
of cardboard.
centuries,
No, it's
not
one
millennia.
piece.
No, he said last
This is a
time that
painting
piece was
from
2 pieces.
1533 called The Ambassadors by Hans Holbein the Younger. It clearly shows two prominent figures, but there's also this distorted shape.
It's crazy
over
they
the
could paint
floor.
like that in 1533.
Only when viewed from the correct
Oh,
position,
look at that piece.
either the top right or bottom left, does it become clear that the image is actually a
skull.
detailed depiction of a human
What?
skull.
Okay, I
It's
missed
suspected
that.
that the painting was meant to be hung in a stairwell, where presumably out of the corner of your eye, you would spot the striking image of the
What?
skull,
Why would they do this? Kinda
reminding you of
creepy.
your own mortality. But if you were to look at the painting head on, well,
can't see
the
it.
skull would be pretty hard to see. Anamorphosis involves making a distorted projection of an object. So to see its proper proportions, you need to look at the work from a particular position or with a
Yeah.
particular device, often a mirror. There are earlier examples like Leonardo's eye by Leonardo da Vinci, which only takes its proper form when viewed from the side. Clearly, Leonardo knew
I'm
how to
learning.
give
I'm actually
side
learning
up.
something right now.
And some might argue that the cave paintings at Lascaux, France from 17,000 years ago provide the first examples of anamorphic art. Due to the uneven painting surface, artists would have had to consider how their animal figures would be perceived from different vantage points.
Makes sense. You've never seen those like pieces of paper that you turn like this and you can read
Anamorphosis
it.
is also central
But
to
when you look
perhaps
head on,
Ames'
you
most
can't read it.
famous illusion,
I know you know what I'm talking
Ames'
about.
room. Ames designed his first distorted room in 1934, and with one eye from one privileged perspective, it just looks like an ordinary room. But when people move around the room,
Oh, yeah, I
it
see
becomes
it.
obvious that something is not
They have one
quite
of those in
right.
LA.
Do they?
Yeah.
Probably not open.
An
Did he
Ames room
build this
is
whole thing for
constructed
that
by
video?
Taking an ordinary rectangular room and adding a diagonal wall through the middle of it. Then draw lines connecting all the key parts of the room, like corners, windows, and so on, to the privileged viewpoint. Mark where those lines intersect the diagonal wall. Then add a floor and a ceiling. If the
It is
projection
really
is
weird
done
to think
properly,
about, like-
they will not only be tilted but also warped. Then
This?
connect the floor and ceiling with trapezoidal
Yeah.
walls, and voila, you have an Ames room.
See, like,
Oh,
look at
yeah.
that.
Yeah. Dang. They have one of those in LA. We should go to it.
Ames
weird.
realized there are an infinite number of different distorted room geometries which, when viewed from the privileged position, create virtually identical images of a normal room. So our perceptions, far from transparently representing external reality, are constantly faced with ambiguity. And our brains, below the level of consciousness, have to decide which of the infinite possibilities we're actually looking at. One form of ambiguity relates to depth perception. Which of these masks protrudes outwards towards the camera, and which is an
The
impression?
right one protrudes
Only
out.
through motion does it become obvious which is which. We are subconsciously attuned to visual cues that indicate how close or far away something is. Closer objects are
That's
typically
LA.
bigger and brighter, plus they obscure objects behind them. But we can play with these attributes in order to create
the heck?
situations that defy our expectations.
Oh, that car's cut in half.
Now, I have been obsessed with getting the Ames window illusion to work. Look at how many different Ames windows I have been making. And I made them small initially and then bigger. There used to be a disco ball in this room. I never thought that this would come in handy. Then I thought about the question, how could I make myself like the ruler that passes through the Ames window? And of course, then I would need a very large Ames window.
I bet his wife is freaking out at him.
I
What
was
is
just-
this?
Living in a weird
Why is there a weird
surreal art
triangle?
museum or something. It needed to be at least 8 feet on its longest dimension.
Oh my
Dang,
god.
that's a lot of
It's
work.
actually made out of 6
Yeah.
pieces of plywood glued, screwed together. One of the challenges is to make it really thin because ideally it should just be 2-dimensional. So we had to bevel these edges here.
Oh, a lot of work. Look at that. Putting that up in the house. If you put that up in my house, I'd be so mad.
He got a whole
So then
crew
I
of
would
people.
twist up these metal cables that hang it to the ceiling and then jump in the window and let them unwind. Okay, so I'll show you some of the best shots I was able to get and you let me know, does this work for you? Do you see it oscillating or do you just
I see it oscillating a little bit,
it
yeah.
actually is?
Oh my gosh.
I found lighting is really important. The lighting needs to be really even on both sides to convince you
Oh, yeah.
that it is
my
really
God.
It does look
oscillating.
real.
Yeah.
When the large side of the trapezoid is close to us, we perceive it rotating exactly as it is. But when the large side moves around to the back, it is still larger in our field of view than the small side.
Oh, yeah.
So our brain perceives
That's a
it
good
as
one right there.
closer and rotating in the opposite direction.
That's so
This
weird.
is why the window appears to oscillate. Half the time we're seeing the window as it is, and half the time we're seeing the bigger side as closer to us, even though it's farther away. But how do we develop the ability to interpret depth cues in the first place? Well, it seems to be an innate ability which forms very early in our development. They've actually shown babies in 3 different age groups, 5.5 months, 7.5 months, and 9 months.
And they put them in the triangle.
Ames window illusion. Do they see the window oscillating? And how would we know if they did?
Yeah, how would
Well,
you know if you
babies
should?
have a well-known preference for novelty. They look longer at things that are new to them. So experimenters first exposed them to an ordinary rotating circle, and then they showed them simultaneously the Ames window and a rotating rectangular window. The 5.5-month-old babies showed no special preference for the Ames window, but the 7.5 and 9-month-olds were significantly more interested in the Ames window, suggesting they perceive it as doing something different, presumably oscillating.
How do they?
The
I don't
reason
feel like that's
I have
accurate
been
though.
so obsessed
Well,
with
it's
this
hard
illusion
too, you
is
know,
because
to
I think it
like-
confronts one of the big misconceptions about science, which is this idea that scientists propose competing theories, and then all you have to do is look at the data to decide which is the best theory. The truth is, there are many circumstances in which the same data could come from very different external
that's
realities.
what he's trying to say.
To use a classic example, does the sun go around the Earth, or does the Earth
go
rotate
around the
on
sun?
its axis?
Oh,
The observation of the sun moving across the sky doesn't in itself resolve that debate. Or to use more modern examples, when you make a quantum measurement, does the wave function collapse? Or does it branch the universe? Is the speed of light
That's why they say,
really
like,
the same in all
studies have,
directions?
like,
or does it differ and only the round
limits
trip
or something
speed
like that.
is seen?
you mean the limit does not
As of
exist
right now,
for
the
Mean
data
Girls?
do not discriminate between those theories.
No, like
And I think we can
or
extend
what's it
this
called when
beyond
the
science.
studies
maybe
have,
the Ames
like,
illusions
faults or
are a
something?
good metaphor
Faulty study?
for life.
No.
it's not
We
faulty, but
feel
just
as
like
though we can
Yeah, that's
directly
crazy.
perceive external reality like a person looking into an Ames room, but the truth is there are an
Are they
infinite
actually
number
looking
of
down at each other,
different
though?
geometries that would all
I don't
look
know. I would
the
have to
same.
look.
You know, these days, a lot of people are getting basically the same fundamental information, but coming to very different conclusions about the state of reality. So I think in that context, it's important to remember that something as simple as a little rotating picture can fool our brains in fairly spectacular ways. So we should approach the world and our conclusions about it with a little more humility and a little less certainty.
Well,
He's gonna be the new Bill
Very
Nye
interesting.
Science guy.
yeah. That was crazy. Very interesting.
Oh my gosh.
Well, that was cool. I'm impressed. All right, guys. Thank you so much for sticking around. We appreciate you. This has been Austen and
Thanks for the
Sarah.
science lesson, Austen.
You're welcome. I'll teach you something every day. I'll teach you something out too. Stick around. Thanks so much for watching.
Don't forget to subscribe and like.
It's been Austen Alexander and Sara Olson. Signing out.
out.
Hey guys, I hope you enjoyed this episode of the Hot Mic Show. If you want to catch more Hot Mic episodes, you can click the link to my left. Or if you want to subscribe, you can click the link below that link. Thanks again. See you in the next episode.